All right, this is the first page of the unit 12, technically, trigonometry notes. The very first page is a like a reference sheet for all of the different trig formulas. We will use a lot of those, but not all of them. That we're not going to do the entire unit because it gets into pre-cal stuff. And if you guys wanted to take pre-cal, you'd be in pre-cal. So obviously, we're going to start with the basics of right triangle and special right triangles. So the Pythagorean theorem is the first thing. And so a squared plus b squared equals c squared is how to find the sides of a right triangle. You guys know this. You've been doing this for a long time. Now, obviously, the ones that we do are not always going to be perfect. We're not going to have like, a 3, 4, 5 right triangle. That'd be too easy. So for one like number 1, you're going to do 4 squared plus 8 squared equals x squared. And that is 16 plus 24, which means that you have 80 equals x squared. And so then you have to do the square root of 80 and of x squared so that you have x by itself. So the square root of 80 is 4 square root of 5. Hopefully you guys do remember how to do that. I'll do this one really quick over here on the side. So there's a couple of different ways to do this. If you know your perfect squares, then you know 80 divides by 16. And so what you are doing is taking the square root of 16 times the square root of 5, because 16 times 5 is 80. So this would have equaled 5. So the square root of 16 is 4. Square root of 5 is 5's prime, so it doesn't have a square root. So that's how you would get that if you know the perfect squares. If you don't know the perfect squares, and sometimes this can get complicated, then you can do the sled method. So the sled method, you take the 80 and you're going to divide it by 2 until you can't divide it by 2 anymore. So you start with the lowest prime number. And so that's 40, 20, 10, and 5. And when you get another prime number on the bottom, you stop. And so then you have pairs, because we're talking about a square root, you're looking for pairs. So you have 2 times 2 on the outside with 5 left on the inside. So this pair of 2's is represented, and that pair of 2's is represented. And then 2 times 2 is, of course, 4. So then you have 4 square root of 5. So that's kind of like a real fast version of how to simplify a square root. If you need more help on that, please let me know and we can go into greater detail. For number 2, we do not know a. So this is represented by an x, of course, but we've got a, b, and c as far as the Pythagorean theorem. So we have x squared plus 22 squared equals 24 squared. So in this problem, you're going to have to do some subtraction. So you've got x squared plus 484 equals 576. Definitely use your calculator for this. And then you're going to subtract the 484. I'm having to write super tiny to get this all in here. So you have x squared equals 92. All right, so then you're going to do the square root to find out what x is. Let me just put a little box around this so that we know. And then I'm going to have to go up to the top of this box to finish this. So when you take the square root of 92, you get 2 square root of 23. So this one, 92 divides by 4, and 4 is a perfect square. 23 is what you get when you divide it by 4, and 23 is a prime number, so it has to stay in the square root. All right, so that's just a real fast rundown of Pythagorean theorem. You guys have done that so many times in your past that we're not going to spend a lot of time on that. All right, for the next section though, knowing and having memorized the special right triangle relationships is very, very helpful in trig. So if this is not something that you have memorized in a previous math class, it will help you to have it memorized as we move forward. So for a 45, 45, 90 degree triangle, what you have to recognize is that the legs are equal because they both are attached to a 45-degree angle. And then we know, of course, that the right triangle has the 90-degree angle. So when you have a 45, 45, 90, both the legs can be represented by x. So if you were to do the Pythagorean theorem on this, you would have x squared plus x squared equals, and I'm just going to do h squared because for hypotenuse. And so you have 2x squared equals h squared. So when you take the square root of this to find out what the hypotenuse is, the square root can only be taken of x squared. So the square root of x squared is x, but 2 is a prime number, so it has to stay in the radical. So the hypotenuse is x square root of 2. A similar situation happens when you have a 30, 60, 90 degree triangle. It's not as easy to show, but what you basically end up with is the short leg. So the leg for this one at the bottom, the leg across from the 30-degree angle is x. And the hypotenuse is twice as long as that short leg. And then the long leg is x times the square root of 3. And so, so that this video doesn't get outrageous, there is a way to show that, but we're not going to go into it. You can definitely find that if you want to Google it. But this is just a ratio that you need to remember. It will make your life easier if you know short leg's x, hypotenuse is 2x, long leg is x to the x times square root of 3. So when you're doing problems with these special right triangles, you have to use this information to your benefit. So if you're trying to find a missing side on a 45, 45, 90, then it's actually easy as long as you have one of the sides. So since we know that one of the legs is 10, that means the other leg needs to be 10 and the other leg needs to be 10 square root of 2. Now you don't have to multiply it back out or anything. You can leave it there with the radical. That's perfectly fine for trig. When you're doing a 30, 60, 90, so I'm going to move down to number 6, then you have a little bit more work to do. So we know that the hypotenuse is 8, so that means the short side is half of 8, so it's 4. And the long side, you have to take that 4 and multiply it to the square root of 3, like so. All right, let's go back to number 4. So number 4, they've given us the hypotenuse and they want us to find the legs. So you have to take 16 and divide it by the square root of 2, because what you're missing is x. So that means you have to be able to rationalize the denominator. So you're going to multiply by the square root of 2 and get 16 square root of 2 over 2, because remember the square root of 2 times the square root of 2 on the bottom makes, you just have a 2 in the denominator because you don't want a square root in the denominator. And then you just do 16 divided by 2. So your answer for both legs is 8 square root of 2. All right. Then you have one like 5. And 5 feels like, oh man, that should be tricky. But it's actually not tricky. The hypotenuse is 14 square root of 2. You have to divide it by 2 to find out what the missing x is. Well, the square roots of 2 just cancel each other out. So it is just 14 for both legs. Now that should make sense if you think about what the hypotenuse equals. If the hypotenuse equals 14 square root of 2, then the leg is the x. It is the 14. So hopefully that's very clear, that that's kind of like a trick question. It makes you feel like it's harder than it is. For number 8, we are given the long leg this time. And so the long leg being 27, we have to divide it by the square root of 3 in order to find what x is. So basically what we're saying is 27 equals x square root of 3. So to find x, we have to divide by the square root of 3. That's also what happened in number 4. So again, we have to do 27 square root of 3 over square root of 3 times the square root of 3 over the square root of 3. So we get 27 square root of 3 over 3. Now this is to find x. This is to find the hypotenuse in this problem. Oh, I'm sorry. No, it's not. It's to find the short side. So we are actually what we're actually doing right now is finding y, not x. I wish they would have used a's and b's on these triangles instead of x's and y's. So what we're finding right now is the short side. So when we do 27 divided by 3, we're going to get 9 square root of 3 for the short side. So then for the long side, you just multiply that short side by 2. So for the hypotenuse, so h here is the hypotenuse, we're going to multiply by 2, so you just get 18 square root of 3, like so. So I'm sorry that I made that confusing because of the x and the y down there. Number 8, they have given us the short side, and they want us to find both the long side and the hypotenuse. Now, this one's the easiest one, because if you look at what the ratio is up here for the 30, 60, 90, the short leg is the one that is used to find the other ones. So to find the hypotenuse, which in this problem is x, you're just going to multiply 10 times 2, so, or 5 times 2, and get 10. I'm trying to go too fast because I don't want these videos to get long, so let me slow it down a little bit. So x is the hypotenuse, and so the hypotenuse is 2 times the short leg, so 2 times 5 square root of 6 is 10 square root of 6. Then to find the long leg, you have to take the short leg. So to find y, you're going to take 5 square root of 6 and multiply it by the square root of 3. So we're going to have 5 square root of 6 times square root of 3. So you multiply the square roots together, so you get 5 times the square root of 18. But wait, that's not all. You have to then simplify that square root of 18. So 18 is, of course, 2 times 9, 9 being a perfect square. So that means you would have 5 times 3 times the square root of 2. So the answer for y is 15 square root of 2. So again, that involves that simplifying and all of that. All right, so I'm going to do these notes one page at a time on the video so the videos don't get really long. So the next one will be in another video.